So the key process of data cleaning is looking at the data set that you've loaded into R and identifying any sort of quirks or weird issues or missing values or other problems that you need to address before you can do downstream analysis. So the first thing that you want to be able to do is summarize the data that you have loaded in. So we're going to be looking at this example data set here, and this is actually a data set about restaurants in Baltimore. And so we've collected this data set again from the web, and so if you go to this URL and then you go to export, you'll be able to see a list of different versions of this data set. We're going to look at the CSV version of the data set. And so we create a data directory, and again, this is the URL that points to the CSV version of the data set that we're going to be talking about, the Baltimore City data. And so we're going to download that file and then read it in with read.csv. So this is what you remember from reading data in from the internet sources. So the first thing that you're going to want to do is look at your data set. So one thing that you can do is just type the name of the data frame that we have. So in this case, it could be rest data. You could just type that in and hit return, and it will return the entire data frame. But often the data frame will be a little bit too big for you to be able to see it all very neatly. So the first command that we're going to talk about is the head command. So if I type head of the data frame that I'm interested in, and I tell it the number of rows that I should report, it'll just show me the top 3, in this case, rows from that data frame. By default, it'll show me the top 6 rows of any data frame. So if I don't give it the end command, or the end parameter, it will just return the top 6 rows of the data frame. The tail command is another command that will give you a little bit of the data set. In this case, it'll show you the bottom part of the data set. So if I pass it this data frame and tell it n equals 3, it'll show me the bottom 3 rows of the data frame. The other thing that we can do is we can use the summary command to get a little bit of an overall summary of the data set that we have. And so what this will do is for every single variable, it'll give you some information. For variables that are text-based variables or factor variables, it will tell you the count of each factor. So for example, in this data set, there are 8 McDonald's and there are 7 Popeyes famous fried chicken. For variables that are quantitative, in this case it's treating zip code as a quantitative variable, it'll tell you the minimum, the first quantile, the median, and so forth. So this has already given us an interesting bit of information because one of the zip codes is actually coded as a negative value, which obviously probably shouldn't have happened. You can also use the str command to give you a little bit more information about the data frame. So here it tells you the class of variable it is. It's a data frame. If it was a matrix, it would tell you it was a matrix. It tells you a little bit about the dimensions of the data frame that you have. And then it also tells you all the different classes that the different columns correspond to. So for example, neighborhood is a factor, zip code is an integer, and so forth. So that gives you a little bit of extra information so that you can know if you need to manipulate things and change quantitative variables to qualitative and so forth. You can use quantile to look at variability in quantitative variables. So for example, if I look at the quantile of the council district variable, if I look at that variable, I see that the smallest value is 1 and the top value is 14 and the median value is 9. So you can also tell it to look at different probabilities. So if I pass quantile probs, it will look at different quantiles of the distribution. So the 0th quantile is the minimum value, the 0.5 quantile is the median, the 99th quantile, you can think of it as sort of the 99th percentile of the data set. So you can do this to look at different percentiles if you're interested in them. You can also make tables. So another way to look at the data is to look at specific variables and make a table. And so in this case, we're making zip code table, and we can see that only one zip code is coded as a negative value. You can also see where the bulk of the zip code values are. So for example, 21201 has a lot of values. So does 21202 and 21224 and so forth. I've added a little bit here to the inside the table command. I say use NA if any. And so what this will mean is if there's any missing values, there'll be an added column to this table, which will be NA, and it'll tell you the number of missing values there is. By default, the table function in R actually does not tell you the number of missing values. So it's important to use the command use NA if any to make sure that you're not missing values. You can also make two-dimensional tables. So in this case, I'm again using the table command, and now I'm passing it two variables, the council district and the zip code. And so now it breaks down a table that's two-dimensional by zip code and by district. And so, for example, you see that District 2 has 27 restaurants in the 21206 zip code. And so you can do this for different qualitative variables and get a sense of the relationship between those variables. The next thing you might want to do is check for missing values. So the function that can be useful there is the is.na function. So if you use the is.na function and apply it to this variable, the council district, and then take the sum of the times its na, is.na will return a 1 if it's missing and a 0 if it's not missing. So if the sum is equal to 0, that means there are no missing values. You can also use the any command. The any command will just look through this entire set of values. In this case, is.na returns true or false, and what it can do is then check and see if any of these values are equal to true. In that case, there would be any value that's equal to na. In this case, none of the values are na, so any returns false because all of the values are false. None of them are na. You can also look at all. All will check and see if, so for example, every single value satisfies a condition. So we would hope that all the zip codes are greater than 0, but it turns out that actually one of them isn't greater than 0, so you can see that again with this all command. Another thing that you might want to do is take sums. So for example, you might want to take sums across columns or across rows. You can do that with the call sums and row sums command. So here I'm going to take the column sums of the is.na applied to the entire data set. So I've applied is.na to the data set, and that will be true whenever there's an na value and false whenever there isn't one. And then I take the sum down every column of that variable, and I see that there are 0 na values for every single variable in this data set. And then I can apply all to the column sums and show that all of them are equal to 0. In other words, there are no missing values in this data set. I can use some other commands to find specific characteristics within the data set. So for example, suppose I want to find all the zip codes that are equal to 21212. I could just use the equals command to see if that's true, but I can also say, are there any values of this variable that fall into this vector over here? In this case, are there any values that are 21212? That's not very useful when you only have one value you care about, but suppose you want to find all the zip codes that are either equal to 21212 or 21213, then you can use the %in% command to say, are there any zip codes that are either equal to one or the other of these values? And so in this case, you see there's a few more. There's 59 values that are equal to either 21212 or 21213. The next thing that you can do is you can actually use this logical variable that you've created by doing this to subset a data set. So suppose I want to get only the restaurants that appear in either 21212 or 21213. I would create this logical variable here with the %in% function, and then I would pass that to the row subsetting component of the rest data variable, and what would end up happening is I would end up with only the rows that were equal to 21212 or 21213 zip codes. The next thing you might want to do is make some sort of summaries or crosstabs about the data sets that you observed. So for example, I'm loading here data on Berkeley admissions data. This is sort of one of the classics data sets in R. And so I can create a data frame using that data set. And if I do a summary, I can see that there are 4 variables: admit, gender, department, and frequency. And so it tells you how many people of each of the different categories are admitted to Berkeley. So one thing that you might want to do is make crosstabs, so identify where the relationships exist in this data set. So what you can do is on the left, this is going to be the variable that you want to be displayed actually in the table. So this is frequency in the table. And then you might want to break that down by some different kinds of variables. So you might break it down by gender, and you might break it down by whether they were admitted or not. So then this tells you the frequency that males were admitted, and this is the frequency that, say, females were rejected. And so when you do crosstabs, you have to tell it what data you want to perform the crosstabs from. One thing that you can do too is actually do crosstabs for a larger number of variables, but they are often kind of hard to see. So here I'm using this warp breaks dataset, which is another one of the standard R datasets. And I'm actually adding in another replicate variable just to illustrate this point. So I've got the replicate datasets, and so I can create an xtabs, again, where I'm going to have the value that appears in the table to be equal to breaks, and I'm going to break that down by all the other variables in the data set. So when I do that, there are 3 different variables I can break it down by. There's replicate, tension, and wool. And so to create a table like this, I actually have to create multiple 2-dimensional tables. This is a little bit hard to see because there'll be a long list of output. You can make flat tables by taking the crosstabs that you made previously and applying the ftable command. And all that will do is it will summarize the data in a much smaller, more compact form, so it's easier to see when you have these large tables. The last thing that you might want to do is actually just seize the size of a data set. So here I've just generated some fake data with rnorm, and then what I might want to do is use the object size command to see how many bytes that data set is. And sometimes that's not very interpretable. You might want to know on a different scale, so you can use the print command and you can tell it what units you'd like to see it measured in, whether it's megabytes or gigabytes or so forth. So those are some ways that you can just take a look at your data when you first load it into R.